isolation of fibrinogen from the blood plasma sample. In order to isolate fibrinogen from a plasma sample, we should take 2 centrifuge tubes, and to one of them we're going to pipette 4 milliliters of blood plasma. And then we should add 4 milliliters of 2 mol per liter phosphate buffer. Use the glass rod to stir the solution thoroughly to help fibrinogen to precipitate. Mix the solution for a couple of minutes. The next step in isolation is to separate the precipitated fibrinogen from the rest of the solution, and we are going to accomplish that by using the centrifuging procedure. Centrifuging is a common laboratory procedure which is used to separate precipitate from the rest of the solution. Each laboratory centrifuge is composed in a similar way. The centrifuge that we are dealing with in our lab has a lid which is opened by rotating this wheel on the right side of the centrifuge very gently, in this case towards the wall, and opening the lid. Inside the centrifuge there is a rotor to which centrifuge tubes can be placed. This rotor is provided for maximum number of 32 centrifuge tubes. But when isolating fibrinogen, we have only one test tube. The most important thing when using the centrifuge is to balance the rotor, which means that we are going to use an additional centrifuge tube of the same weight or by adding the same volume of the solution as in our experimental centrifuge tube. So we have to position our tubes, and the best way to position it is to position it oppositely. When the tubes are positioned in the rotor, lid is closed to hear the click. So when the lid is closed, now we have to switch on the centrifuge by pressing the button from 0 to 1. There are several indicator lamps and wheels to be explained what they are used for. So the first thing is to explain the components of this, let's say, cockpit. We have the first wheel, which actually is used for adjusting the speed of centrifuging expressed in rotations per minute. Second wheel is a manual brake, which is not normally used, only in incident situations or emergency situations. And the third wheel is used to adjust the time of centrifuging. Also, here is a scale with a needle, an analog scale, which is used to follow the accomplished speed of rotation, expressed in numbers multiplied by 1,000. There are also 4 indicator lamps on the cockpit. 2 of them are red lamps and 2 of them are green lamps. The first red lamp is warning lamp, and when it's on, it warns us that the lid is not properly shut down. I'm going to show you an example. If it's properly shut down, the red lamp switched off. The second indicator lamp is also red colored, and when it's on, it informs us that the rotor is not balanced properly. The third indicator lamp, which is green colored lamp, is on when centrifuge is working. And finally, the fourth indicator lamp, which is also green colored, indicates the moment when the centrifuge is slowing down automatically. So, when we want to start the centrifuge process, first we have to adjust the time of centrifuging. According to the procedure, that is going to be 10 minutes. After that, we have to speed up the centrifuge, and according to the procedure, this is going to be 3,000 rotations per minute. We should speed up the centrifuge slowly, following the needle on the scale. When the needle reaches number 3, then the speed of rotation is requested 3,000 rotations per minute. Very important thing is that you should not leave the centrifuge work alone. And if it starts to make noise, you should call the technician immediately or stop the centrifuge by yourselves. So when the time is up, the automatic brake is on and centrifuge is slowing down. Till those two lamps are on, you cannot open the centrifuge lid. But in the meantime, you may bring the speed of centrifuging to 0 again. So now lamps are off and we can open the centrifuge in the same manner as previously. Let the rotor completely stop and take out the centrifuge tubes. So the precipitate is separated from the rest of the solution. Precipitated is possibly fibrinogen, and now we have to discard the supernatant. In the next step, we have to pipette 5 milliliters of 1 mole per liter phosphate buffer. Now resuspend the precipitate with a glass rod. Centrifuge the solution again. For second centrifuge process, we shall open the lid again, and according to the well-known principles, again position our test tubes or centrifuge tubes to opposite positions in rotor. Close the lid to hear the click. Again, adjust the time to 10 minutes and slowly the speed to 3,000 rotations per minute. Again, precipitate is separated from the rest of the solution. Now we have to discard the supernatant and add 1.5 milliliters of 0.25 moles per liter phosphate buffer. Again, take the glass rod and dissolve the precipitate. It may take a couple of minutes. So when fibrinogen is dissolved, now we have to prove that the precipitated protein is actually fibrinogen and that the biological function of it remains unchanged, meaning that upon addition of 2 or 3 drops of thrombin, it should turn to fibrin. So now we're going to add a few drops of thrombin. Mix the test tube and keep it in hand for a couple of minutes. If the fibrin is formed, that is the proof that the isolated protein is actually fibrinogen. So after a couple of minutes, we can test what is going on in our test tube. So as you can see, fibrin is formed, which is insoluble in water and in the form of a gel. So if you turn the centrifuge tube upside down, the gel form remains firmly attached to the test tube, and that is the proof that we actually isolated fibrinogen from our sample blood plasma.